Greetings and welcome to the series of lectures on rational expressions and rational functions, 5.2, multiplication and division of rational expressions. The good news is the process of multiplying and dividing rational expressions is incredibly similar to fractions. So if you remember, if we had two fractions, AB, and we wanted to multiply it by another fraction, CD, all I do is multiply the numerators, multiply the denominators, and then I want to make sure that it's in lowest terms. Multiplying rational expressions is exactly the same thing. Likewise, with division, when we multiply by the reciprocal for division, we're going to do the same thing for rational expressions. So let's recall the process for multiplying fractions. So let's say I have a fraction of 6 sevenths times 14 eighteenths. That means it's going to be 6 times 14 over 7 times 18. What I can do is break down each of the values into its factors and then see what the numerator has as well as the denominator has, and I can reduce that because any value over itself except 0 over 0 is a 1. Okay? So 6 can be broken down into 2 times 3, 14 can be broken down into 2 times 7. 7 is just a 7 because it's prime. 18 is a 3 times 2 times 3, or 3 times 3 times 2, or 2 times 3 times 3. It doesn't matter what order. I can see in the numerator I have a 2, a 3, a 2, and a 7, and the denominator I have a 7, a 3, a 3, and a 2. Because they share a 2, a 3, and a 7, that only leaves a 2 in the numerator, 3 in the denominator, so my final result is 2 thirds. Alright, so let's try it with a little bit more complicated problem. I have 8x cubed all over 27y to the 8th times 9y to the 3rd over 12x squared. Okay, so the first thing I want to do is break these values into its factors. 8 is going to be 2 times 2 times 2. X is just x cubed. I'm going to go ahead and leave it as x cubed. 9 is 3 times 3, and y is y cubed. Be consistent there. That is all over. 27 is 3 times 3 times 3 times y to the 8th. 12 is going to be 2 times 2 times 3 times x squared. I want to reduce this as much as possible. 2, 2. Okay, I have a 3 in the numerator, another 3 in the numerator. Okay, so let me just rewrite to see what else, so what we have left here. I have 2 in the numerator with an x cubed y cubed. I have a 3 times a 3, which is a 9. Let's see, I've got an x squared and a y to the 8th. Now I do need to remember my exponential rules here. That's going to be 2 ninths, x 3 minus 2, y 3 minus 8, giving me 2 ninths. 3 minus 2 is a 1. Y 3 minus 8 is a negative 5, but I don't want to leave my exponents in negatives. So let's bring the y back down to the denominator. 2x all over 9y to the 5th. That is my final answer. My final, well, I suppose I did the operation multiplication as well as simplify. Right, for rational expressions, it's going to be very similar. I want to figure out the factors and then see what the numerator has and what the denominator has. So let's factor each of the fractions, and I'm going to do that separately. So x minus 3, that's all I can do. Parentheses are just there for emphasis. x squared minus 4 is going to be x minus 2, x plus 2. That is all multiplied by x plus 2. Again, parentheses there are for emphasis. X squared minus 6x plus 9. That is going to be x minus 3 times x minus 3. Now that I have it all factored, let's kind of squish it all in together because it's all multiplication. Put it under one fraction. X minus 3, x plus 2, all over x minus 2, x plus 2, x minus 3, x minus 3. As long as the numerator has the same thing as the denominator, it's a big fat 1. So the whole entire x minus 3 over x minus 3 is 1. X plus 2 over x plus 2 is 1. The only thing left on top is a 1. Therefore, 1 over x minus 2, x minus 3. That would be our solution. If you wanted to, you could multiply out the denominator. It's going to be 1 over x squared. Minus 3 and a minus 2 is a minus 5x, and a negative 2, negative 3 is a plus 6. You don't have to do that last step, but yeah, that's the answer, right? Not so bad. Figure out its factors. Reduce before doing the multiplication. It would be kind of difficult to figure out how we'd reduce if we did all the multiplication first. So figure out its factors, reduce, and then do the final multiplication if needed. All right, factor first. I'm going to factor each of these fractions. All right. Might have to do it in a couple of steps. 2, I can actually pull out a 2y. Leaves me y minus 2 all over. And pull out a 2 here, leaving y squared minus 1. That's the first step for that one. Let's see. Y minus 3, y plus 1. Negative 3 times 1 will give me negative 3, and negative 3 plus 1 will give me the negative 2. Right. Got a positive but a negative, therefore they're both negative. And, well, 6 and 1 doesn't give me the 5, but 2 and 3 does give me the 5. And 2. Okay. So I think the first thing I want to do is reduce the individual fractions first, and then carry it forward to see what happens. All right. It's little steps. 2 over 2, that will go away, and the y minus 3 and the y minus 3 will go away. So let me rewrite what I have. Y minus 2 all over y squared minus 1 can be factored. Y plus 1, y minus 1 times y plus 1 over y minus 2. Right. They're still two separate fractions, but now I can put them as one fraction. Y minus 2 times y plus 1 all over y plus 1, y minus 1, y minus 2. All right. We can reduce again, as it turns out. Y minus 2 and y plus 1. There is a 1 still up there in the numerator. So the whole entire problem ends up reducing all the way down to 1 over y minus 1. Okay, that's kind of cool. All right, so let's deal with division now. let's first start with division with fractions and then use that same process as in division of radical expressions as well as radical functions. All right, so 6/8 divided by 3/5. First thing I want to do is change the division by multiplication by the reciprocal. So now I have 6/8 times 5/3. I can put it all under one fraction and reduce. 3 goes into 3 once, 3 goes into 6 twice, as well as 2 goes into 8 4 times and 2 goes into 2 once. 1 times 5 is 5, and I'm left with a 4 in the denominator. Okay. So following the same procedure. All right, so let's try one with expressions. All right, 8x cubed all over 5y squared divided by 4x squared all over 10y to the 6th. First thing I want to do is rewrite it as multiplication of the reciprocal. 10y to the 6th all over 4x squared. Now that I have it multiplication of the reciprocal, I'm going to combine them into one fraction. 8x cubed times 10y to the 6th all over 5y squared times 4x squared. Now I'm going to start reducing. 4 goes into 4 once, 4 goes into 8 twice, 5 goes into 5 once, 5 goes into 10 twice. Okay, just to clean it up, it's going to be 2 times 2 is 4, x cubed, y to the 6th, all over, well 1 times 1 is 1, I don't need that in the denominator, so I won't rewrite that, but it is x squared y squared. Now I just need to deal with the exponents of the variables. 4x3 minus 2, y6 minus 2. Therefore, 3 minus 2 is 1, so it's x. y6 minus 2 is 4, y to the 4th. There we go. All right, let's work with a little bit more complex problem. X squared minus y squared all over x squared minus 2xy plus y squared divided by x cubed plus y cubed all over x cubed minus x squared y. All right. First thing I'm going to do here is I'm going to multiply by the reciprocal. Right. X squared minus y squared. Oops, sorry about that. All over x squared minus 2xy plus y squared times x cubed minus x squared y all over x cubed plus y cubed. Okay, now that I have it rewritten, I'm going to factor each numerator and each denominator if I can. Right. X squared minus y squared is going to be x plus y, x minus y. X squared minus 2xy plus y squared is going to be x minus y times x minus y times. Just keeping them separate for now. I'm going to squish them together in a second. I can do an x, and that would leave x squared. I can actually pull out an x squared, leaving x minus y. It's just kind of my workspace right there. And then x cubed plus y cubed is a perfect cube. That's going to be x plus y times x squared minus 2 minus xy, oops, plus y squared. Sorry about that. Oof. Okay, now I can consider this all under one fraction. I'm going to cheat and not rewrite the whole entire thing. whatever is on the top, if it is also in the bottom, I can reduce. X plus y, x plus y. X minus y, x minus y. X minus y, x minus y. That leaves me x squared in the numerator, and in the denominator, x squared minus xy plus y squared. Excuse me. Now, I know you might be tempted to reduce this x squared and the x squared, but keep in mind, I cannot do that. We cannot do that because we cannot cross the subtraction and addition. These are 3 terms in the bottom and 1 term on the top. I cannot cross this subtraction and addition. So that is my final answer. It is as reduced as I can get it. All right, let's throw the kitchen sink at you here. Okay, I have multiplication and I have division. So the first thing I'm going to do, personally, I'm going to go ahead and factor each numerator and denominator. And while I'm doing that, I am going to multiply, change this to multiplication of the reciprocal. So first let's just figure out all the factors. All right, a squared minus 8a plus 15. It's going to be a minus 5, a minus 3, all over a plus 4, times a plus 2, all over a plus, minus 3a minus 2, divided by, again, I'm just going to factor everything first, a minus 5a plus 2, all over, all right, that's got to be 4 and 2, where 4 is the positive. There we go. Okay, one last thing. I'm going to multiply by the reciprocal of this third term and put it all under one fraction. A to the minus 5, a minus 3, a plus 2, reciprocal, a plus 4, a minus 2, all over a plus 4, a minus 3, a minus 2, a minus 5, a plus 2. All right, now it's time to reduce. A minus 5, a minus 5, a minus 3, a minus 3, a plus 2, a plus 2, a plus 4, a plus 4, a minus 2, a minus 2. This whole thing is a 1 over a 1, which is a 1. Wow, a lot of work for just 1. Kind of cool, too, that ended up, it looked like a big fat mess in the beginning, but it all ended up multiplying to 1. Kind of cool. All right, let's try another problem. Generally, when we have 4 terms, you're going to use grouping to factor. So let's go ahead and group. I'm going to just go ahead and group it kind of as it sits. I'm thinking of grouping it into 2. I'm not quite aligning it perfectly with the signs. I'm just kind of thinking of them in groups of 2. So XA plus XB will factor into X times A plus B. YA plus YB will factor to YA plus B. All right. Denominator. XA minus XB will be XA minus B. Negative YA plus YB. I can factor out that negative Y. That will leave me a and negative b, because negative times a negative will be that positive right there, minus b. Okay, so the first term is factored, times. All right, x, a plus b. And let's go ahead and factor out a minus y out of here. Minus y, leaving me a plus b. Right. Denominator will be x, a minus b. And we can factor out a negative y again, a minus b. All right, one more step to factoring. X plus y, let's factor out this a plus b. X plus y, all over a minus b, x minus y, times x minus y, or let's factor out the a plus b, and the x minus y. Factor out the a minus b, leaving behind x minus y. Just want to check my work here. Okay. If I factor out a negative y, that's going to be, yeah, negative b, that makes sense. And I just want to make sure, oh, I should have factored out just a y, positive y. There we go. Thought something looked weird there. Okay, found my mistake, yay. All right, this is all going to be on one fraction, a plus b, x plus y, a plus b, x minus y, all over a minus b, x minus y, a minus b, x plus y. Is there anything that we can cancel, or is there anything we can reduce? Yes. X plus y, x plus y. X minus y, x minus y. I cannot do a plus b and a minus b. That just won't work. So my answer, a plus b squared over a minus b squared. That's my final answer. Let's do a couple more examples. Okay, before I do any multiplication, I'm going to factor this expression and pull out a 4 x squared minus 9 times 12. I'm going to factor the denominator, 4x plus 3. For the x squared minus 9, I can factor that as well. So it's going to be 4x minus 3x plus 3 times 12 over 4x plus 3. Now I'm going to go ahead and combine it. I can say that there's a 1 underneath here. So that's going to be 4 times 12 times x minus 3, x plus 3, all over 4 times x plus 3. Now I can reduce. 4 goes into 4 once, 4 goes into 4 once, x plus 3 goes into x plus 3 once, x plus 3 goes into x plus 3 once, leaving 12x minus 3. Not so bad. Not so bad. All right, similar problem, but actually the first term is already factored. So the only thing that I need to factor is this x squared minus 3x plus 2, if possible. Okay, 3x minus 2, x minus 1 times 5 all over. I know they're both the same sign and both of the signs are negative. 1 and 2 will multiply to 2, but 1 plus 2 will be 3, 2, 1. Now I'm going to rewrite this all under the same fraction. 3 times 5 times x minus 2, x minus 1, all over x minus 2, x minus 1. Reduce. So I'm only left with 3 times 5, and 3 times 5 is 15. All right. That's it for this lecture. Until next time, be seeing you.